So let's go over these summary functions one more time and all the things that we've seen that we're able to do with any of these containers, really. I just want to be super clear that these containers are very similar in many ways, and then they're different in specific ways. What we have in a list and a tuple really are the same things. With a list and a tuple, we have an ordered list that has non-unique items. The only thing that makes a tuple any different is that it's read-only. When we run this, we're going to see results related to, well, I've got it here in the comments really. We see results that relate to the values involved. Sum gets us a float sum, len gets us the number of items, max gives us the maximum number, the minimum number, and then sorted gives us a list of items that have been ordered according to numeric. Another thing that we've done is use the in operator. With the in operator, which usually is used with if, we will get back true or false depending on whether that item is within that container. What's really interesting about this, however, is that it doesn't really matter which container we use. So I can easily just convert this to a tuple by changing it using the parentheses, and now it's a tuple. All of the features work in the exact same way. We see the exact same results, and I would show them to you here, but I want to keep to this screen. This is obviously going to go through each item. But it doesn't matter which one we use. We can easily convert it to a set. Now, a quiz question I might ask you, just now that we've learned about the nature of lists, tuples, and sets, is how will this output change if I change my sequence to a set? In order to answer that question, you do have to understand the two things that make a set different than a list or a tuple. And those two things are, what are they? They're unordered, so we don't know which item is going to come first, and they're unique, which means that duplicates will be removed. As you can see, this item is duplicated, this item is duplicated. I think that's it. So our result is going to be very different, isn't it? Our sum will probably be different because it's not summing up those values anymore. It's summing up the unique values. So yeah, our output is 14.7. Our len is now 5 because the two duplicates were removed. The max and min don't change because we didn't change the actual values that are in there, so the max and min are going to stay the same. What we removed were the duplicates, and then of course the sorting will get us a sort of the set, which means that there's still a list and they're still in order, but there are only 5 of them because the duplicates have been removed. And does the in operator change? It's not going to change with this statement because we only asked for an item that's in there. And by converting to a set, what did we do? How was the values changed? How were the values changed when we converted from a list or a tuple to a set? The answer is the order changed and the duplicates were removed. And that's what makes a set a set. In every other way, however, sets, tuples, and lists work the same way, and that's the emphasis of this video. So that, of course, means that the only thing that we couldn't do with a set that we could do with a list is ask for the first item or for the first 3 items or for the middle 3 items. So if I ask for, let's say, the first item, or I ask for, let's say, the last 3 items, will that do it? I think so. Yeah. I can do that with a list. So I should see 3.9 and then I guess 2.9, 3.9, and 2.1, which I do. But what if I turn this into a tuple, will that work? Certainly, it's an ordered sequence. So yeah, but what if I were to, and I can run that. It's not going to look any different, except we get a tuple slice rather than a list slice. But what if we were to change the braces to a set? How will this code run now? See if you want to pause and think about it before you answer. So the answer, of course, is that line 6 will fail, and line 7 would fail too. Why? Because a set object, it's not only just that a set object does not support indexing, it's that a set object doesn't have the concept of a first item. It's regardless of the fact that when you loop through a set, you'll see the first item that comes out of the set. That's not the point. The point is the set's order doesn't matter to us. It matters to Python when we ask it to do membership tests. And this is a review of what we talked about with sets. It matters to Python if we ask Python to do membership tests, because Python is going to be very efficient when it goes looking for an item in a very big set. And that's what the order really is about. But the order doesn't matter to us, and that's why the set doesn't support indexing. If it allowed you to, let's say, get the first item, and that first item happened to be 3.9, if it allowed you to do that, it would imply that that set is keeping an order. But the fact is, the set's order may change at any time. So, in summary, with the tuple and the list, we can do order-based types of operations. Other than that, any of these other operations, which we should become very familiar with, and you will want to become familiar with as time goes on, will be possible with any of the containers we've looked at. Summing them, getting the length of them, getting the max or min, sorting them, checking for membership in them, or looping through them. Take a look at all of these operations and make sure they all make sense, and realize that eventually you're going to memorize all of them because they're all really, really useful. One very small side note with sum and max, or sum rather, is that sum does require that all the items be numbers because you can't sum up strings. So that's just the one limitation on using sum. Otherwise, it'll work perfectly with all of the containers.